form is going to be a second form of writing equations for us. We've already talked about point-slope form. So reminder, here's an equation where we are given the point -2, 3, and we're given a slope represented by m as slope of -2. So if I put my points on here, and sorry, it's not very easy to write on the screen. Here's my point -2, 3, and if I use my slope of down to right 1, slope is -2 over 1, down to right 1, or up to and left 1, the negative sign can go with the numerator or the denominator, then here is my line. The point, or the form we're going to talk about today can also be used to write equations of lines, and actually maybe the form that many of you are more familiar with. So I'm going to take this equation and I'm going to solve it out, and this goes along with your notes. I'm going to solve it out for y by distributing and then getting y alone. So I get y equals -2x minus 1. Now, this form is the form that we're going to be looking at as our second form that we are writing for our equations, and this is called slope-intercept form. Remembering that mathematicians are not creative, this is called slope-intercept form because, and this is the same equation for the same line, because from this form you can still see the slope. So the slope of this line is -2. And then this -1 piece, so there's -2, this -1 slope-intercept form corresponds to the y-intercept. So you can look on our graph and you can see that the graph crosses the y-axis at -1 at the y-intercept. So when we're looking at slope-intercept form, this is your general format. It's much simpler and much more straightforward than maybe point slope form is. It's going to be, again, you have your input and input and output values, your input x, your output y. What we are going to be using is the slope of the line, and then b is the y-intercept. Reminder, y-intercept, where we cross the y-axis. The coordinates of your y-intercept, if it's on the y-axis, that means the x value. Whoops, ignore that. The x value is 0, and the b value, that y value, is what you'll see in the equation. Much more straightforward than point slope form, but possibly you need to have more information or different, more specific information. The y-intercept is not just any old point. In point slope form, you can use any old point. But in slope-intercept form, you have to use the y-intercept as far as writing your equation. So for slope-intercept form, we're going to write a couple of equations here. The first one, again, these are just meant to be very simple examples. Thinking about your general format is the y is alone. The slope times x plus b means I'm going to take the slope and plug in it as m, and the y-intercept, the value for the y, as b. So I'm going to plug those two values in, and I don't know why that keeps happening to my screen. We're going to ignore it. So slope is -3, b is +5, so plus b, so I just plug in 5 for b. There's my equation, y equals -3x plus 5. Pause, and you get a chance to do this problem. Now that you've come back, again, the format, y equals mx plus b, the slope is your m value, the y-intercept is the b value. So we're going to take those two values now and write our equation. So y equals, plug in the slope of m, or sorry, plug the slope into m. Talking and writing is hard. And then plug in the b value. So this would be plus -1, so we can rewrite this as y equals 7x minus 1. Unlike with point slope form, notice if you see a -1, then your value was -1. It's by the nature of the format for the equation. So there's no opposite values going on like with point slope form. Now, what happens when, instead of being given the direct information that I need, what happens when I don't have the slope, when I don't have the y-intercept? The answer is you need to find those values. So if you're given 2 points, those 2 points could be from a graph. Those 2 points could be just given to you. You're going to need to find the equation through them. There are two methods. I'm going to go through just one of the methods here, and I'm going to write the second, just instructions for the second method. The first method that I'm just going to give you the description of is to go through and actually take the information you're given and write out point slope form and then turn it into slope intercept form. So we've written, if you need to look at an example of this, we've written point slope form equations from 2 points. And on the very first slide, the very beginning of your notes today, you change point slope form into slope intercept form. The second method here, and this is what I'm going to go through, is to actually go through and find your M, I'm sorry, that keeps happening, and B values. I'm not sure why that keeps happening. To find your M and your B values on your own. So the first thing we're going to find, the first thing that's easiest to find, when you have 2 points, what's going to be you're able to find is your slope value. Your slope is equal to, and I'm going to use the slope formula, y2 minus y1 over x2 minus x1. I'm going to go through and calculate. So I'm just going to name these x1 and y1, x2 and y2. We found the slope several times, so this should be no big deal. Subtract your y's on top. Subtract your x's on the bottom, and I have -1 over -1 plus 3 becomes +2. So my slope is -1/2. Okay, so first thing you're going to do is find the slope. Oops, sorry. The next thing you're going to do is I'm going to actually now go ahead and write my equation with as much information as I had. So I have y equals -1/2 x plus, I don't know the b value. So at this point, I've written the equation with the slope, but I need to know what the y-intercept is. So how can I find what that y-intercept value is? I'm going to actually do some solving. So what I'm going to do is actually, I know another part of this equation that I haven't added in. I know an x and a y. Actually, I know 2 sets of x and y. So I'm going to pick one of my points. It doesn't matter which point you choose. I'm going to choose the point -1, 3. This gives me an x and a y that I know goes with this equation. So I'm going to plug in y, and I'm going to plug in x. And now the only variable I have left in here is b, which means I can use some solving. I can multiply my slope and the x coordinate. I can get b alone, and I can solve and see that once I get b alone, that b is equal to 2.5. So I found my m value, I found my b value. Instead of being told those, I found them. So now I can write my equation as y equals -1/2 x plus 2.5. So my slope and my y-intercept are shown as part of my final equation. If you prefer to use point slope form, that's fine. But this way uses a lot more of our algebra skills as far as using the solving for a purpose. So I'm going to give you a chance to pause and try this one. If you're stuck and you need some help, remember that you start with the slope. So I'm going to go ahead and start with the slope. My slope is subtract my y values over, so 6 minus 4, subtract my x values, -6 minus -2. And I end up with 2 over -4, which I hate this, but it's happening on my screen, which I end up with -2/4, which is -1/2. I'm going to write my equation with as much information as I know right now. I know y equals -1/2 x plus b. And now I'm going to choose one of my points. It doesn't matter which one. If you chose a different point, then you're fine. All that matters is you have an x value and a y value that are the part of that line that you're plugging in. So I have 4 equals -1/2 times -2 is +1. And now I'm going to solve for b. So I get 3 is equal to b. Once you have your m value and your b value, you're going to plug those in and write your equation. Y equals -1/2 x plus 3 should be my equation. Now, how can I double check to make sure this is actually my equation? You could take your other point, so I have -6, 6, and I can plug in those points, that x and that y, and this should be a point that's on the line. If it's not, so this is 3 plus 3 is equal to 6, check. If the point is not on the line, then that tells me I made a mistake somewhere in my setup. Both points that you have are given should be points that are on your line, so you could plug them in and check and make sure they work. So we've now written equations in point slope form. We've written equations in slope intercept form. We have different forms of linear equations, and we're going to be responsible for working with all of them. The 3 different forms that we have seen thus far, 2 of them, so I'm going to star these 2, and these are going to be just examples for us. 2 of these are ones that you are actually going to be responsible for writing the equations from information like points or information like a graph where you would have to pull some points off of. The third form here in the middle, you're going to be responsible for using, but we're not going to be writing that one as much from just information on a graph. So the 3 different forms that we have, you're going to need to be able to, and we'll work on looking at characteristics, but you're going to be needing to know what each form is and what each form shows. So for this first one, this is written in slope-intercept form. Slope-intercept form is y equals mx plus b. For the second one, again, this is the one you aren't going to necessarily be writing as much, but you're going to be using. This is called standard form. This is ax plus by equals c. Notice it's a capital B versus the lowercase b. That means they stand for different things. And the last one here is point slope form, which is y minus y1 equals m parentheses x minus x1. Now, regardless of the different forms, we're going to be able to pull some information out of each different equation. We'll talk about which equation gives you the best information and different cases where you want to use each of them. But one of the skills we need to have is being able to change between the different forms of equations. So what our goal here is we're going to be giving, and what's the advantage of getting, say, solving for one variable in an equation is that it's changing the format into giving you different information. So for instance, here's for our I do 2 equations where you are given a point slope form on the left. So this is point slope, and you're given standard form on the right. So this is point slope, and this is standard. The idea is if you take either equation and you solve it for y, which is a skill we have done this school year, we did in the very first algebra unit we did, that you can get your equation now. If you solve for y, get y alone, you now have your equation in slope-intercept form. So if I take a point slope form equation, I can distribute y minus 1 equals 2x plus 4. Make sure you're careful about your distributing. You'd be surprised how often we forget to do the 2 times 2 there. And add 1 to both sides. If I get y alone and combine all my like terms, now I have an equation in slope-intercept form. The same thing we can do with standard form. Right now I have it in my equation in standard form. I can get y alone by, this is the process we have done, add 6x to both sides, and then divide both sides by 3 to isolate the y variable, and I can get 2x plus 5. What you may not have noticed in each of the equations, because they were written in very different formats, is these actually were showing the same equation, just in different formats. So you're going to pause, and you're going to try the you do here, and I will show you the answers with the last few seconds here. Since we only have a few seconds left, I jumped ahead and just put the answers on. These are not the same equation, unlike the I do's. We're showing the same equation. But if you look through this process, pause, take a look at the steps. These are steps you should be familiar with. Try and decide what happened. But those are the 2 answers, and solving for y will get you your slope-intercept form